the hunt for new planets is far from over. While scientists have already discovered more than 7,400 exoplanets, Earth's true cosmic twin still eludes us. Yet, it's possible that the next habitable world lies much closer than we think. Take Proxima B, for instance, located just 4.2 light-years away. This rocky planet isn't just any celestial object. It orbits within its star's habitable zone and might even host life already. So, what have researchers uncovered about the closest exoplanet to Earth? Could Proxima B be our long-awaited Earth 2.0? And is it really true that the James Webb Space Telescope may have spotted signs of a glowing alien city on its surface? Stay with us until the end as we dig into these fascinating mysteries. No star comes closer to our solar system than Proxima Centauri. This red dwarf is just 4.24 light-years from the Sun, a seemingly short cosmic distance. But in real terms, it's staggering. A single light-year equals the distance light travels in a vacuum in 1 year, an astounding 9.46 trillion kilometers. In simple terms, the distance between the Sun and Proxima Centauri exceeds 40 trillion kilometers. Even though it's one of our closest stellar neighbors, it remains far beyond our current reach. With the propulsion technology we have today, it would take thousands of years for a space probe to cover that vast distance. NASA and other space agencies are actively exploring ways to turn interstellar travel into a reality. However, there's still no clear timeline or certainty about when, or even if, these ideas will come to life. For now, we must accept that getting a closer look at Proxima Centauri is out of our grasp, and that's certainly a disappointment. After all, this star doesn't journey through space alone. According to what we know so far, Proxima Centauri hosts at least 3 planets. The most recently discovered, Proxima D, is about a quarter the mass of Earth but lies too close to the star to be within the habitable zone. Proxima C, farther out, may be a mini Neptune. And then there's Proxima B, discovered in 2016, which has captured attention as a possible Earth-like twin. Is Proxima B truly Earth 2.0? And how do scientists even detect a planet located tens of trillions of kilometers away? Do they simply aim advanced telescopes at a target star and capture the alien world on camera? Not exactly. In reality, most exoplanets are discovered using indirect detection techniques. The most effective of these is the transit method, which is responsible for identifying about 70% of all known exoplanets. This method works by observing slight dips in a star's brightness caused by a planet passing in front of it. However, Proxima B wasn't discovered this way. Instead, astronomers used the radial velocity method, a technique that detects tiny wobbles in a star's motion caused by the gravitational pull of an orbiting planet. These wobbles show up as regular shifts in the star's light spectrum. Even if the movement is just a few centimeters per second, it can still betray the presence of a hidden planet. What makes Proxima B even more intriguing is its location. It lies within its star's habitable zone, the region around a star where temperatures could allow liquid water to exist on a planet's surface. But while liquid water is a critical ingredient for life, it's only part of the bigger picture. Much more is needed to determine whether a planet is truly a second Earth. Other elements, like atmospheric composition or radiation from the host star, can still prevent life from developing, even if many conditions appear favorable. So, what about Proxima B? With a mass of approximately 1.17 times that of Earth, it's classified as an Earth-like exoplanet. However, this label can be misleading. Earth-like simply means it's a rocky planet with a solid surface. It doesn't imply that it's actually habitable. Unlike Earth, which takes 365 days to orbit the Sun, Proxima B completes its orbit in just over 11 days, owing to its close proximity to its parent star. While the average distance between the Earth and the Sun is about 150 million kilometers, Proxima Centauri and its planet Proxima B are separated by just 7 million kilometers. At first glance, this close proximity might suggest that Proxima B's surface is blazing hot, and that's partly true. However, there's more to the story. Proxima Centauri is a red dwarf star, with a mass only about 12% that of our Sun. Despite its closeness, it emits far less energy. Another critical factor is that Proxima B doesn't rotate on its axis like Earth does. Instead, it's tidally locked, meaning the same side of the planet always faces its star. As a result, Proxima B is split into two starkly contrasting hemispheres, one in perpetual daylight and the other in eternal darkness. This might seem like an environment too extreme for life. But surprisingly, that might not be the case. Scientists believe that between the scorching day side and the frozen night side, there could exist a narrow, twilight zone, a band with milder temperatures that could potentially support life. Even more intriguing, simulations suggest that this twilight region might be sustained by water from glaciers on the cold side. As these glaciers melt near the habitable zone, they could form rivers and lakes, providing the liquid water essential for life as we know it. Has Proxima B already developed life? Unfortunately, we can't say for sure, at least not yet. Whether liquid water exists on Proxima B, and by extension, whether life could arise there, depends on several factors that scientists have not fully confirmed. However, based on favorable assumptions about its orbit and atmospheric conditions, a 2017 simulation suggested that cool, liquid water might indeed be present on the planet's surface. Even so, the question of Proxima B's habitability remains highly controversial, largely due to the extreme behavior of its host star, Proxima Centauri. Researchers from the University of Colorado made a startling discovery that stunned the scientific community. While our sun occasionally emits powerful bursts of radiation called solar flares, what scientists observed from Proxima Centauri was on a completely different scale. The red dwarf released a flare 100 times more powerful than any ever recorded from our sun, causing its ultraviolet radiation to surge by a staggering 14,000 times within seconds. Interestingly, the eruptions on Proxima B are not only significantly more intense than those in our solar system, they also occur far more frequently. Given this, it's reasonable to assume that the planet's atmosphere could eventually be stripped away by the relentless stellar radiation, wiping out any possibility for life. But is that truly the case? Not necessarily. There's a potential scenario in which Proxima B manages to retain its atmosphere. For that to happen, the planet would need a liquid core capable of generating a stable magnetic field, which could shield it from Proxima Centauri's harmful radiation. Such protection could preserve both water molecules and oxygen on the planet. Another theory suggests Proxima B might still be holding on to its original water reserves. According to this idea, the planet may have formed much farther from the star and was only later pulled in by Proxima Centauri's gravity. In fact, it's possible that Proxima B once possessed up to 10 times more water than Earth. Even if 90% of it has already been lost to radiation, the remaining amount could still support a vast ocean covering much of the surface. However, due to the planet's unique rotation and orbital characteristics, any water would likely remain at moderate temperatures only within the narrow twilight zone, where day meets night. Has the James Webb Telescope really photographed a city on Proxima B? Why are we still speculating about possible water sources and harmful stellar radiation when, supposedly, the James Webb Telescope has already captured what looks like an artificial sea of lights on Proxima B? To add fuel to the fire, members of the Breakthrough Listen project previously detected a potential radio signal from the Proxima Centauri system. Is the evidence finally clear? Unfortunately, not at all. In reality, neither of these claims holds up. The so-called city lights are actually a highly generous misinterpretation of an entirely different observation. What Webb actually observed was a remarkable methane-based light display near a brown dwarf named W1935, completely unrelated to Proxima B or any alien civilization. As for the radio signal, yes, it was of artificial origin, but with a critical detail: it came from Earth. The signal, labeled BLC1, turned out to be a distortion caused by terrestrial radio interference. So, despite all the excitement, the famous "wow" signal from 1977 remains the most compelling candidate in our search for extraterrestrial contact.